Hello everyone, welcome back to Coding Charms. In today's video, we are going to be solving the problem same tree. Given the roots of two binary trees P and Q, write a function to check if they are same or not. Two binaries two binary trees are considered to be same if they are structured identically and nodes have the same values. So the two important points to note here is the two trees are said to be similar if they have structured identically and their nodes have the same values. So let us see examples. Given the first example, we have the structure looks identical. Both of them have one root node and two children. Let's check the values. Here we have 1, here we also have 1, here we have 2, here we have 2, 3, 3. So the node values are also same, structure is also identical. So the two trees are same. We return true. And coming to here, we have root node, and on the left, in the first tree, we have two node on the left side. But in the second tree, we have two node on the right side of the root. So these two are the values are same, but the structure is not same. So we return false. Here, again, the structure looks identical, but the values, let's check the values. Here we have 1, here we have 1, root node is 1. And on the left subtree here, we have 2. But on this, in the second tree, the left subtree has value 1. So the values are not matching. So the values are not same, we return false. Here the structure is identical, but the values are not same. So this is the problem. How can we solve it? So the solution looks pretty straightforward. There are some cases. Let's consider what are all the cases that we can have. So first, what if the given both nodes are null? If P is null and Q is also null, in that case, our tree is same. So both are null, then the structure and values are also same. So we return same. Case 2. What if P is not null and Q is null? In that case, it's not same. This is this case where we have left side. In the first tree, we have left side, but here we don't have left. So this value is present. P is not equal to null, but Q is equal to null. This is the condition there. And we have third case where P equal to null and Q not null. This is the other case. So in this case also, we can say not same. Next, case 4. What is the case left? When P is not equal, P is equal to null, Q is equal to null, P is not null, Q is null, P is null, and Q is not null. The other case is P not null and Q also not null. In this case, we again have to check what? The values. We have to check the values. If P dot value is equal to Q dot value, then so far we have the same subtree. Now we have to recursively check if is same of, recursively have to check P dot left and Q dot left. Then we recursively have to check for P dot right and Q dot right. If they are same, then we can say whole tree is same. If this is not the case, if P dot value is not equal to Q dot value, then it's not same. So these are all the conditions. Let us code it up. So if P equal to null and Q equal to null, in this case, we return true. If P not equal to null and Q equal to null, in this case, we return false. And if P equal to null and Q not equal to null, in this case also we return false. And lastly, we have case if last case is P, that's by default, right? If these cases are not executed, by default we come to this case. So we can now directly check if p dot value is not equal to q dot value, then we directly return false. Else we recursively check is same for p dot left and q dot left and p dot right and q dot right. Then we return is same tree of p dot left comma q dot left, and we also check for right p dot right comma q dot right. Looks good. Let us run it. Passes the sample test cases. Let us submit it. It passes all the test cases. So what will be the time complexity of this approach? The time complexity of this approach will be O of 1. We will check for all the nodes in both the trees. So the time complexity will be O of n. What will be the space complexity? The space complexity will also be O of n, because O of n, or you can say O of h. If we consider the recursive call stack, the recursive call stack will be at most O of h. H means height of the binary tree. So that's it for today. I hope you understood today's problem. If you did, make sure you like this video and subscribe for more daily videos. Keep practicing. See you in tomorrow's video.